All right, let's keep going here with example 3. So, once again, we're still going to solve, but now what's looking a little different is that we just have more than just a number on the right side of our equation. But that's fine. But we'll do it. Don't worry about it. All right, here we go. So example 3, we are going to solve and identify anything extraneous. All right, so we got a here. It's going to be the square root of 3x minus 2 is equal to x minus 4. Now, right off the bat, I'm telling you, I told you that I promised you that using the parentheses was going to help you out, and here we go. So, we are trying to solve for x. That's great. On one side, we have x isolated, but on the other side, we got x locked into a square root. So we can't have that, right? We need to get our x's together. We need to get them collected, but I can't be putting an x together with some x that's locked under a square root. So we got to unlock that from the square root. And we know, of course, right? Guys, our general rule of thumb should be get all your variables to be full, to be whole, right? We talk about whole parts. Get those radicals out of there. Get everything to be whole parts. So look, as I was saying that, look what I did. How do you undo a square root? You square both sides. And sure enough, look at this over here. Watch, I'm going to do this again. I'm going to back this up. Oh, come on. Right? You need to use parentheses, guys. You are squaring this entire x minus 4 side of the equation. So I told you it was going to pay off. Sure enough, paying off. All right, here we go. Square cancels the square root. 3x minus 2. Now, this really means, right, x minus 4 quantity squared. So, repeat the parenthesis. That looks like something we're going to have to FOIL. So what? We got it. All right, 3x minus 2. First is x squared. Outside negative 4x, inside negative 4x, so that'll be a negative 8x. Last, negative 4 times negative 4 makes it a 16. Okay, now, this goes back. This is like chapter 2, people. This is like chapter 2 all over again. Now we have a quadratic. So we got x squareds, we got x's, we got numbers. It's a quadratic. We know the first thing you got to do when you solve a quadratic, yeah, exactly. You got to set it equal to 0. Perfect. So let's get this minus 3x. Let's add this 2. Let's minus 3x. Let's add this 2. We're combining a few steps together here. So what? We got it. We're algebra 2 people now. We got it. All right, so negative 8x minus 3 more, so negative 11x plus 18. So now we have a quadratic set equal to 0. Yes, absolutely. Factor it. Boom. So what multiplies to 18 adds to negative 11, so we know we're going to have a minus minus because we're adding to a negative, multiplying to a positive. Sure enough, we're all thinking in our heads, hey, that looks like 9 and 2. Absolutely. So if x minus 9 is 0, that means x is 9. If x minus 2 is 0, that means x is 2. So now, before we go claiming that these are both solutions, we need to do the same thing, is that we need to test. So test it in the OG. So go back up to the original. Let's test 9. So look on the left side. 3 times 9, 27. 27 minus 2 is 25. Square root of 25 is 5. Look on the other side, 9 minus 4. Boom. Sure enough, is 5. Checks out. Now we got to test 2. So go back to 2. 2 times 3, 6. Minus 2 is 4. So we get something that looks like this. If we test x equals 2, we get something that looks like this. The square root of 4 is equal to 2 minus 4. Okay, and I know what we're thinking. Oh, well, the square root of 4 could be positive 2 or negative 2. No. Yes, but no. No. When you're taking the square root of a number, not the square root, not when there's a variable involved, not when there's some x, not on one side, the other side, no. The square root of 4 by mathematical, natures and laws and all these things. It's just the positive. We're going to focus on just the positive here. So that's going to be 2, okay? So the square root of 4 is 2, and sure enough, 2 minus 4 is negative 2, so that's no good. So we see that x minus 2 is extraneous. Extraneous doesn't work, so our only solution here is x minus 9. Now, we're not going to go through this, but I want to show you here kind of what I want to walk you through kind of what this is showing here. Okay? It says x equals 2 is extraneous, but why? Okay, so we got to think about this. If we were to square both sides, right? You know, we're gonna graph. We're gonna use it by showing a graph. So I don't know, because then you can look at it and you can see it, right? So if you look at these two graphs, clearly, right, the eyebrow function, this square root function, this eyebrow function, it doesn't go over here towards negative 2, right? It doesn't go, or excuse me, it doesn't go over there at 2. What am I doing here? It doesn't go over here at 2. It doesn't cross. I don't know. Whatever. So then, apparently, when we square both sides, now we use the squaring to help us solve, but it's not really true to the original graphs, right? Originally, we had a graph that was an eyebrow and a line. Through using squaring to help us solve, now all of a sudden we have a line, and oh, look at that, we have a parabola. But that's not really what the original was talking about. Again, we use solving equations, we use inverse operations as a way to help us isolate our variable. But when you go back to the original, guys, we're not talking about a line and a parabola. We're talking about an eyebrow and a line. And sure enough, those two things do not intersect at 2, because, I mean, you can just see it. They don't. It's no good. So that's why back in the original, when we test it out, just go with the fact that 2 is the square root of 4. We'll stick with the positives, and therefore it doesn't work. It's extraneous. Boom.